So some funny things can happen with wait times. For example, let's think about the wait time of buses at a particular bus stop. Let's say the average wait time is 60 minutes. This does not mean that there's 60 minutes between buses. Because if you think there's 60 minutes between buses, then on average you might arrive in the middle of that interval and you would think that you expect to wait 30 minutes. That's not what this means. If the average wait time is 60 minutes, that means, like, let's say all the buses are the same distance apart, then the wait time would be 120 minutes between buses. And you expect to arrive in the middle of that interval, and your average wait time is 60 minutes. It may not be so evenly spaced, but on average, the interval is 120 minutes. That makes your expected wait time 60 minutes. So let's look at a slightly more complicated example than that. So in this example, half of buses arrive 90 minutes apart and half of buses arrive 30 minutes apart. And the question is, how long do you expect to wait? The answer might be a little bit unintuitive. So first, let's think about the probability that you arrive at a time when the interval between buses is 90 minutes. Okay, well, since it's half and half, then we can just think of total time as 30 plus 90 and the time desired as 90. So your probability of arriving in a 90-minute interval is 3/4. And we can do the same for probability arriving in a 30-minute interval. It's just going to be 30 over 30 plus 90, and that is 1/4. So your average interval is going to be 3/4 times 90 plus 1/4 times 30, which is a total of a 75-minute interval. We expect to arrive mid-interval, just like in our previous discussion. Mid-interval. So this means our expected waiting time is 75 over 2 is 37.5 minutes. The answer might be a little bit unintuitive, but this is correct.